Hi, this is Asing. You are now watching Asing Math TV. We are given a function of x and asked to estimate its value when x is equal to 0.52 using Maclaurin series. Always bear in mind that when finding Maclaurin series, we can exclude any terms that can be treated as polynomial, which means that instead of differentiating the function f(x), I'm going to let gx be equal to x multiplied cos x. At point x is equal to 0, anything multiplying 0, we get back 0. Let's differentiate the function with respect to x. Since it is a product of two functions, let's apply the product rule. If you are not familiar with product rule, let's do it step by step. We can let u be equal to x while v be equal to cos x. Determine their derivatives. When we differentiate u with respect to x, we obtain 1. Differentiate v with respect to x, we obtain negative sine x. Recall that according to the product rule, when we differentiate u v with respect to x, we obtain u dv dx plus v du dx, which means that if we differentiate x cos x with respect to x, we should obtain x negative sine x plus cos x multiply 1, which is simply equal to x negative sine x plus cos x. At point x is equal to 0, again anything multiplying 0 we get back 0, and cos 0 is equal to 1, which means that this is equal to 1. Let's differentiate the function for the second time. Again, for the first term, we can apply the product rule, but this time we should let v be equal to negative sine x, and therefore dv dx is equal to negative cos x. By using substitution, when we differentiate x negative sine x with respect to x, we should obtain x multiplying negative cos x plus negative sine x multiplying 1, and this is equal to negative x cos x minus sine x. Don't forget, we have the second term, that is cos x. So when we differentiate cos x, we obtain negative sine x. Simplified, we should obtain negative gx minus 2 sine x. At point x is equal to 0, negative g0 is 0 minus 2 times of sine 0, which is again 0, and this we have 0. With this substitution, we can differentiate the function easily. That is, when we differentiate gx, we should obtain the first derivative, and differentiate sine x is simply cos x. Therefore, at point x is equal to 0, we should have negative. For the first derivative, at point x is equal to 0, we have 1, and we minus 2 times of cos 0, which is equal to negative 3 at the end. Now let's differentiate the function with respect to x for the fourth time. Again, differentiate first derivative, we obtain second derivative, or the second order. Differentiate cos is negative sine, and we know that negative multiply negative, we obtain positive. At point x is equal to 0, we have negative 0 plus 0, which is again 0. Differentiate the function for the fifth time, and we should obtain negative third order plus 2 cos x. At point x is equal to 0, the value for the third order is negative 3, and cos 0 is 1. 1 multiplying 2, we obtain 2, and this is equal to 5. Since the sixth and the higher order contribute the value that can be neglected, I'm going to stop differentiate further, but from the Maclaurin series for the function gx. If we have difficulty in using the formula, let's follow this hack. Always start from 0, so we should have 0 factorial and multiply x to the power of 0, leaving the numerator blank. And now move on to the next term. After 0, we should have 1 factorial x to the power of 1. Next, we have 2 factorial x to the power of 2, and followed by 3 factorial x to the power of 3, 4 factorial x to the power of 4, and 5 factorial x to the power of 5, and so on. Next is to substitute all the values for the respective order at point x is equal to 0. For the original function, we can treat it as 0 order. So 0 order, we should put it here. That is, we put 0 here. First order, we have 1. Second order, 0. Third order, -3. Fourth order, 0. And for the fifth, we have 5. Simplify, we should obtain anything multiplied 0, we get back 0. So any term with 0 as the numerator can be ignored since it contributes no value. So I'm going to remove these 3 terms and we left 1x minus 1 over 2x cubed plus 1 over 24 x to the power of 5 and so on. Next is to determine the Maclaurin series for the function f(x). We are given f(x) is equal to x cos x plus x squared, which is simply equal to gx plus x squared. And this is equal to x minus 1 over 2 x cubed plus 1 over 24 x to the power of 5 and so on plus x squared. We arrange the terms, we obtain x plus x squared minus 1 over 2 x cubed plus 1 over 24 x to the power of 5 and so on. Next is to estimate the value when x is equal to 0.52. With the calculator, I'm going to first take 0.52 and store it to any alphabet, let's say x. With this, we can minimize the time in pressing the calculator, especially when the values consist of many decimal places. Follow the Maclaurin series that we have, which are alphabet x plus alphabet x squared minus 1 over 2 alphabet x cubed plus 1 over 24 alphabet x to the power of 5. Press on equal and we should conclude that f 0.52 is approximately equal to 0.722 to the nearest 3 decimal places, and hence we done. Okay, that's all for this video. Thanks for watching. Hope you like this. See you.